Okay. Another thing I found out about the derivations and stuff. So you don't have to know the compound angle derivation. It's a long, crappy one, right? The one you'll need to know is the double angle derivation. So I'm going to do that with you all today. Okay, so the double angle derivation is on page 109. Because I found it from another maths as well, and I was double checking syllabus and stuff. They don't ask you to do, because if you look at page 106, 107, right? It's a very long derivation for compound angle. So what they do test you on is the double angle, and remember the other day we did the co-ratio one. Guys, derivation for co-ratio?
Yes, sir.
That one, right? There were the two triangles. So they do test you on that, and then they may test you on the double angle derivation. So I'm on page 109 where it says double angles. Right? And this is the derivation for how you would derive it. Okay, it's one of the most difficult derivations ever. Right? I'm going to show you. So, you know your compound angle rule, right? Like, say for example, what is the first one they give you? Sine A plus B. Sine of A plus B. Using compound angles, this would be sine A cos B plus sine B cos A. Right? That's our compound angle. Now, what happens in the instance where you have sine of A plus A? Okay, there are two terms. What happened if the two terms was the same thing, like your sine 30 plus 30 or 45 plus 45? This would now become sine of A cos A plus sine A cos A, right? And then sine of 2A is equal to 2 sine A cos A, and that's your double angle. That's the whole derivation. Huh? Difficult, huh? That's the whole derivation, right? If you look at the page over there, they basically show you it's just two lines. How you would derive your double angle, you would take your compound angle rule, right? And with your double angle, you have two of the same angles. So, instead of A plus B, you'll have two of the same things, like A plus A, B plus B, so on. So, you substitute it into your compound angle formula as normal, and these two terms are the same thing. Right? So you can just add it. If you look at along page 109, you will see it's the exact same thing for how you would do cos. Cos is, you know where they say sine 60. They got cos A plus B is equal to cos A cos B minus sine A sine B. That's your compound angle formula, right? So if you end up with cos A plus A, you're going to end up with cos A minus sine A sine A, which is cos squared A minus sine squared A, which is how you get the rule for double angle. Okay? You understand that? Yes?
Okay, I'm lost, but...
Okay.
Oh, yeah.
So this is for sine, right?
Alright.
This is for sine. For minus, you'll understand it will be the same thing, right?
Yeah.
Okay. So, if we give you cos of A plus B, compound angle formula is cos A cos B minus sine A sine B, right? Compound angle formula for cos A plus B. Agreed?
Yeah.
Now, if you had cos of A plus A, this would now become cos A minus sine A sine A. And this here, cos A times cos A is what? Cos squared A. So, cos of 2A is equal to cos squared A minus sine squared A. This is your double angle formula that I gave you, right? And remember, for cos, you could get two other ones, right? You get the one where you have cos squared A is equal to 2 cos squared A minus 1. What it is?
Yes.
2 cos squared A minus 1. Now you may be wondering how they got that, right? So this is one formula. Remember along the line somewhere I showed you one where you have cos squared A plus sine squared A equal to 1.
Yeah.
Right? Now if I make cos squared A, sin squared A the subject of the formula, this becomes sin squared A is equal to 1 minus cos squared A. Right? If I substitute it over here, it's going to become cos 2A is equal to cos squared A minus 1 minus cos squared A, which will become cos squared A minus 1 plus cos squared A, which will become 2 cos squared A minus 1. And that's how you got it. If you want the other one in terms of sign, you would have made cos the subject of the formula, substituted it here, and came to the same thing. So you all understand?
Okay.
Okay? And then for tan, it's the same thing. Tan is towards the bottom of the page. You're just basically showing your compound angle formula. You're showing the same angle for both, and then you just substitute. So for tan, remember for tan, for a compound angle, tan of A plus B is equal to tan A plus tan B all over, what is it?
1 minus tan A.
Right? So you'll say if tan A plus A would be equal to tan A plus tan A all over 1 minus tan A, right? This will become on the top 2 tan A all over 1 minus tan squared A. And isn't that your double angle formula for tan? So you'll see how easy it is. Even, remember, okay, but they do give you the compound angle and double angle formulas. But if you don't ever remember your double angle formula, but you can remember your compound angle formula, you can literally get it so fast because all you need to do is substitute the same angle. And then you sort it.
If the one was minus, first one, right?
Yeah.
Sign, then what would your answer be?
Minus 2 sine A cos A. No.
Oh no.
I like.
Cancel.
It would be.
Cancel.
A equals A minus sine equals A.
If your double angle formulas for sine minus, what is that?
To
No, you don't get minus because it will be sine of 0.
Sine of 0 there.
If you look at your compound angle formulas the way I gave you, you can see how I have sine A plus minus B. But if you see the double angle formula, I just got sine 2A. It's basically 2 times the angle. It's not.
Cancel each other.
Yeah.
Oh,
If it cancels each other out, it's going to become 0. So there's no negative for that.
But for the compound one, you do here.
Yeah, compound will do it.
But in the book you do have it.
Where?
Cos squared A is equal to
No, cos is different. Cos goes opposite way.
Where you got cos squared A is equal to?
cos squared A cos 2A is equal to cos squared A minus sin squared.
Yeah, that's this here.
And
Cos
then-
2A is equal to cos squared A minus sine squared A.
Yeah, because cos.
He is talking
Yes.
about here. If you have sine of A, and if I say sine of A minus A,
Yeah.
that's nothing after
Cancels
that,
out.
right? It's going to cancel itself out.
Yeah.
So even same thing over here, if I say cos of A minus A, it's going to become cos of 0.
Same angle, yeah.
Which is, I think cos of 0 is 1. So it starts with 12. Yeah, it's 1. Okay, so guys, this is a derivation they will both, if you do test your rates, it will probably be this one, right? Not a difficult derivation, very simple to understand. For double angles, remember your compound angle formula, substitute the same angle. As you do the rest, it will be very easy.
So how would they ask for this one?
They'll ask you to, they'll probably show you, or they'll say, prove that sine 2A is equal to 2 sine A cos A. And then you will have to say, sine, you should show this compound angle formula, you'll show the step here, and then you show the path. That's it. That's it.
So they won't put angles in there or anything like that.
No. This is just like a proving.
Just proving.
You're gonna see today now the questions I'm gonna do with yours. How are we doing on 10? And I'm trying to do. Of course, I'm trying to do a lot with this maths for cheap. Yeah. Because then if I know we can clock it now, And today also you'll be able to see the beauty of past year papers, right? And then I hope it may make you all go and do past year papers. Okay, yeah, so you can highlight page 109. It's important. Did you all go over those rules I gave you all for check?
Everything that we got.
It's about 2 pages of it.
Yeah.
So you'll see today when what I'm doing, that page is going to be important to you all, right? Because I'm going to keep on referring to it.
Oh, the rules is super
No, everything that we got.
Yeah, Tim must try to copy it off of
Oh,
right?
yeah.
Hope you like it, Tim.
That's on those two.
See, for mine, I don't know.
Shut up a minute.
You'll see one.
You must just delete the whole thing.
Yeah.
They usually before them say it's coming.
Really?
Yeah. And it looks they're doing coming.
Come for the exam.
With no DP. If I'm also the exam.
I don't know. Yeah, I don't know. Oh yeah.
If they do test any derivation, I hope they test this one. It's easy. If they do, they'll probably test this one. Because then you have to show that, science very plus that is equals that, subject to the formula or something.
Ten is different. It's got a division.
Yes, take it up.
Yeah, a minute.
Which side you on? That's it.
I'm done with the top part, just on the bottom part. I'm done. I don't know about the rest.
Guys, okay, take it up.
Yeah.
Okay, so you'll know the derivation of co-ratio, you'll know the derivation of double angle. So deriving is okay. Let's get into some past year paper questions. These questions I'm looking at now is from the 29th June 2022, and this is the trig questions that came up, right? So first question they asked you was simplify without using a calculator, and then what they gave you was okay. Seems difficult, is it? No. Shouldn't, right? So, how you start this now? Let's look at our first one. Sine of 180 minus x. Right? 180 minus is which quadrant? Second quadrant. What is positive in the second quadrant? Sine. So this would just come out to sine of x times tan of 90 minus x. 90 minus is what? No. When I gave, what I did the other day with you? Saturday?
Yeah.
What was the section I did? Saturday is lecture? Co-ratios. Remember what we were looking at in co-ratios? 90 plus 90 minus. I don't know why I'm looking at you guys. 90 minus that. So, tan of 90 minus is what?
What?
Guys, your page. Right? Look at the page under co-ratios. Cot. Right? So this will change into cot x. You'll understand that?
So we are applying all.
Yes, absolutely.
That's why I told you it's better I do past year paper with y'all, because y'all will see all the rules one time, and that you're obviously going to have to answer it like that, right? So, cot of x, right? Cosec of 90 minus co-ratios again.
Sec x.
So that will turn into
Sec x.
sec x. 360 minus is which quadrant? Fourth. What is positive in the fourth?
Cos.
Cos. So this will just become cos of x, and then 180 minus is which quadrant? Second, right? Second quadrant, what is positive? And
Cosine.
cosec, right? So cot will be negative cot x. Do you understand?
Oh, just because it's negative in
Oh
the
no, sorry, I
second
wrote
quadrant.
it wrong. It's supposed to be plus. Okay. But in terms of that, right? Remember the only two things that are positive in the second quadrant is sine and cosec, right? Cot falls under the third quadrant, so it will be negative in the second quadrant. Okay?
Because you're 80 plus. and
But now it is
third
180
quadrant.
plus. 180 plus is third quadrant. What is positive? If you go back to that same page we did, that our cheat page, you will see in the third quadrant cot and tan. So it will be a positive. You understand this?
Yes.
Okay. Now what will happen? That and that will cancel, agree? It's all being multiplied. So you left with sine of x all over. What is that? Remember how I told you to remember this? The third letter of this
Cos.
would be what it corresponds to. Third letter of this is C. C for cos. So this would be 1 over cos of x times cos x. What happened? Cancel, cancel. So you left with. Can you simplify any further than that?
No.
Do you understand why they say simplify now? Without the use of a calculator. Never use a calculator at all. You just apply the rules. When you see 90 minus or 90 plus, generally it means you have to use your co-ratios. Okay? If you see 180 minus, 360 minus, you would use cast diagram.
Okay.
Good. Okay.
So
I'll give you time to
class
take this down. Let me
minus-
just carry on for a bit there.
So that's why you changed because of that that's the same rule that you were just telling us.
The
now.
co-ratios. You need to watch Saturday's video, gentlemen. I need to post Saturday's video. So I'll post Saturday's video and then you watch it, right? I will post it. I'll post it there. Okay, 1.2.
Yeah.
Yes. And that's what I remember. That's another.
Okay, this is the question, right? Prove the following identity. So they want you to prove that this side is equal to that side. Okay? Now normally when they give you a question like this, you would normally have one side that's simplified to a point where it can't simplify any further, and you'll take the, like if the right hand side was simplified to its furthest point, you would just say left hand side, you will solve the whole thing and you make it equal to your right hand side. But now you can see both can be simplified more. Okay, because you can break up cosec, you can break up cot, you can break up sec, you can break up tan. Right? So you will start with one side. Okay, so let's start with our left hand side. Our left hand side is sec alpha all over 1 plus tan alpha. Right? So let's start simplifying it. Sec breaks up into what?
1 over cos.
1 over cos. So this would be 1 over cos alpha all over 1 plus tan is what? Sine alpha all over cos alpha. Right? Okay. Now,
That, yeah, so bring everything to cosine and sine, right? Or and tan.
you try to bring things to what you can cancel it off with. Like see, the moment we change this into cos, we know now we want to try and get rid of stuff. Tan is not going to get rid of cos. The only way it's going to get rid of it is if we try to do something here. So how do you continue simplifying this? Anybody got an idea of how we can simplify this further?
Subtopic.
How are you going to rotate it back? You want to make fraction over fraction? Is that what you want to do?
So multiply.
Multiply by? Cross multiply.
So.
How? See, if you see a fraction over a fraction, normally you would inverse it, right?
Yeah.
But we got the 1.
That's the problem.
How are you going to invert that? Now remember 1,
Number one.
right? The number 1. Anything over that
This one.
is 1. So what would be the best thing to make it over? Over what over what?
Cos over
Cos over cos, right? Because cos is your denominator here. Okay? So you would end up with 1 over cos alpha all over cos alpha over cos alpha plus sine alpha all over cos alpha. You understand this, right? Okay. Then you will end up with 1 over cos alpha all over cos alpha plus sine alpha all over cos alpha. You can see it now, right? Now it's a fraction over fraction, and what you do with that, you would say 1 over cos alpha, and you would invert this. So this would become cos alpha all over cos alpha plus sine alpha. And what will happen now? Cancel, cancel, and you're left with 1 over cos alpha plus sine alpha. Can that simplify any further? No, right? We're not going to get anything that we can simplify further. So that's how we know we simplify it to its furthest point. Is that equal to this?
No.
No. So what we need to do with this one?
Simplify.
Simplify it as well. Okay? So, why do I not have markers here? So now you'll see right hand side. Okay? The right hand side is cosec alpha all over 1 plus cot alpha, right? This is exactly like how we did this side. We're going to break up now on this side. Cosec is what? 1 over sine alpha all over 1 plus cot. And what is that?
Sine over opposite. So cos over sine.
So tan, if tan is sine over cos, cot would be cos over sine, right? Because it's inverse. Okay, so this would be cos alpha all over sine alpha, right? Now, same scenario as here. We want to make it both the same denominator. All you need to do is, you will say 1 over sine alpha is equal to sine alpha over sine alpha plus cos alpha over sine alpha. This will become what? 1 over sine alpha all over sine alpha plus cos alpha all over sine alpha. Now you will invert it. So this will become 1 over sine alpha multiplied by sine alpha all over sine alpha plus cos alpha. What will happen? Cancel, cancel. 1 over sine alpha plus cos alpha. And this is equal to that. Remember, it's the same thing. Cos alpha plus sine alpha is the same as sine alpha plus cos alpha. Now your left hand side is equal to your right hand side. You prove that this is equal to this. Now you see how you have to keep on applying trig rules now. It's not only you're going to get one question where you only tested on cast diagrams. No. You're going to get questions where you have to use cast, special angles, co-ratios, compound, double angle, everything in one. Right? Yeah. Okay.
And so basically when it proves in there, you'll see that the answers should be equal to each other.
Because if they tell you prove it,
Yeah,
and it's between equal, it has to be equal to each other.
So then there won't be another way where they say prove and then it doesn't add up.
No, if they're telling you prove that it's equal, it means that they're telling you this is equal at some point. Show that
I'm
it's
just saying
equal.
that just make sure.
Right? And also with trig, guys, when you do trig, if you can break up something, break it up. Right? Like see when you came to this point now and you are about stuck now, you're figuring, hey, what I'm supposed to do. And you have probably did the same thing over here and thinking now, hey, what do I do? Right? But you wouldn't have had the same thing because remember here you're going to have 1 over cos alpha is equal to 1 plus sine alpha over cos. And here you got 1 over sine. That's not the same thing. Right? So you know you have to break it up further. That's where the 1 will come into play. Okay? Guys, remember that? Can I do one more question then you can take it up?
Yes.
Okay. Okay, so the question is, determine the general solution of the following equation. 4 cos squared x into x over 2 plus 40 degrees is equal to 3. Right? General solution is where we would normally start solving for x and all the values of x. Right? So now what we'll do, we'll simplify this formula. So you'll divide by 4, so you'll end up with cos squared x over 2 plus 40 degrees is equal to 3 over 4, right? Then we're going to need to get rid of the square side. So what you do, you square root. So you square root, you're going to end up with cos x over 2 plus 40 degrees is equal to the square root of 3 over 4. Okay? Now you want to basically get a reference angle. You know the angle we use when we're starting to solve for the quadrants? No one would have done that with you.
Yes.
Okay? So you will press shift cos that. Okay? So to get your reference angle, you're going to have x over 2 plus 40 degrees is equal to cos, so minus 1 of root 3 over 4. So your reference angle is now 30 degrees, right? Okay. Now you're going to have to solve for the values of x. Another thing is, remember when you square root a number,
Plus minus.
you end up with a positive and a negative value of that number. So, what that basically told us was that this value is for your positive and negative quadrants. So when you're solving for your values of x, you can't only solve for the quadrants where cos is positive. You need to also solve for the quadrants where cos is negative. Right? So you're going to work all 4 quadrants using this as a reference angle. So I'm going to say for my first quadrant, x over 2 plus 40 degrees is equal to, what are the conditions in the first quadrant? Nothing, right? You don't need to add, you don't need to subtract anything. So you'll just say 30 degrees. So far guys, you understand what I'm doing here, right? Okay. So you take your 40 across, x over 2 is equal to minus 10 degrees. X is equal to minus 20 degrees. So that's one value of x. Good? Good. Right? Your second quadrant, x over 2 plus 40 degrees is equal to, what's your condition for second quadrant? 180 minus. And it's 180 minus your reference angle. So this is 180 degrees minus 30 degrees. So x over 2 is equal to 180 minus 30 is 150 minus 40 110. You'll understand by that? Okay. Then x is equal to 220 degrees. That's another value of x. Right? Now we need to do for the quadrants where cos is negative. No, well, cos is negative there. Say that. Okay. Third. So you'll say x over 2 plus 40 degrees is equal to, what's the condition for the third quadrant? 180 plus. So this will be 180 degrees plus 30 degrees. X over 2 is equal to 180 plus 30? 210 minus 40? 170. Right? X is equal to 340 degrees. That's another value of x. Agreed? Right. Last quadrant.
360 minus.
Okay, so the condition for that is 360 minus, and then it will be 360 minus 30. 360 minus 30? 330 minus 40? 290. So x over 2 is equal to 290, x is equal to 580 degrees. Right? So these are all your values of x. So x is approximately, you'll write it in order from smallest to biggest, minus 20, 220, 340, 580. Does anybody understand that? Is anybody confused about that?
So at the end we need to write it like
The values for x.
Is that the same thing as writing the solution set? Or no?
See, sometimes for this question, they don't show you when they give you the mark. They'll just show 5 ticks over there as long as you have all the steps.
Okay.
But it's nice to just show all your values of x, right? Guys, do you understand what I did there?
Yeah.
So when you determine the value for x, we go to all the quadrants.
So see, because in this instance here, when you square root a number, remember you get a positive and a negative number. So that means cos of whatever this is equal to a positive and a negative number. So when you're solving for that, you need to solve for all the quadrants because of the negative and positive. If you didn't square root and you had positive 3 over 4, you only need to solve for your first step one, the quadrants where cos is positive. Okay? And then all this here after that is okay after that, right? Okay, so now I'll give you some time to take it done. Pause the meeting.
Just like typos.
Yeah. Right. This is a question. Find the value of 1 over cot 75 degrees without the use of a calculator. Wonderful, eh? Right. So, 1 over cot 75 degrees. Okay? What is cot? But no, the other one, the earlier one. It's just 1 over 10. Right? So, this would be 1 all over 1 over 10. Right?
Yes.
What is this?
It's just 1075.
Why is it 1075? It's a fraction over a fraction, right? You can't have a fraction in the denominator. You will multiply by the inverse. But if you multiply by the inverse here, you're going to end up with 1 over 1 times 10 75 degrees over 1, right? Which is just 10 75 degrees. Right? Now, what do you do?
Use a special
Yes,
angles.
special angles.
45 plus 30, right? So, this would now go 10 of 45 degrees plus 30. Do you all understand why we chose 45 plus 30? What 45 and 30 are what? Special angles. Special angles, we can get the numbers from the triangles without using our calculator. Okay? So, this here, 10, 45 plus 30 is what? What would you use to simplify further? Look at it. We got two angles. Two different angles. Include the other one. Compound angles, right? So, compound angles for 10. Are you understanding? Well, you're looking. You're okay. You're okay then? Okay. So, what's the rule for compound angle rule for 10? It will be 10 of A plus 10B all over 1 minus 10A, 10B. So, this would be 10 of 45 degrees plus 10 of 30 degrees. 10A plus 10B all over 1 minus 10A, which is 45 degrees, times 10B, which is 30 degrees. Yes? Yes. Now we'll use our triangles. So go to the page I gave you a tutorial to write down. What is tan 45? 1. Alright? 1 plus tan 30. Square root 3 over square root of 3. All over. 1 minus tan 45 is 1. Tan 30 is root 3. So what is this now? It's 1 plus root 3 all over 1 minus root 3. Do we need to simplify further? Yes, we do. We do need to simplify further. Okay? How would you simplify further? Okay, so show tan 30 is 1 over root, is root 3 over 1.
Yeah, that's it.
Okay, so this here is actually 1 over root 3, 1 over root 3. Right? So you got 1 plus 1 over root 3, 1 minus 1 over root 3. Yes?
Yeah.
So, what would you do? Remember I said we can't have a fraction in the denominator, right?
Okay.
But our problem is the 1. What we do with the 1? What we did in that first question?
Make one root 3 over
The same as that one, right? So, this would be 1 plus 1 over root 3, right? All over root 3 over root 3 minus 1 over, agreed?
Yes.
Right. This will now become 1 plus 1 over root 3 over root 3 minus 1 all over root 3. Right? Now you will multiply by the inverse. So you have 1 plus root 3 multiplied by
Root 3 minus 1
over root 3 minus 1. Right? Can you simplify further? Let's take that out from there, right? From the bottom. So, how would you take it out? Same thing, right? So you will say here root 3 over root 3 plus 1 over root 3 being multiplied by root 3 over root 3 minus 1. Yes? Yes. So this will now become root 3 plus 1 all over root 3 multiplied by root 3 all over root 3 minus 1. Yes? No, so we cancel the bottom 2 and then what you left? That and that cancel. Root 3 plus 1 all over. And that's 1. Okay, but this part here, you would have done it here one time. I just didn't want to do both together because it may confuse you. So I just broke up the denominator, then I broke up the numerator. Right? But later on when you're redoing this example, you can try and practice doing it at the same time. But everywhere over here, do we understand what's going on?
Yeah.
Okay. I can take this one down because then I'm going to do a new part of it. So you see this question here, you applied your rules.
So
for
what's
what?
wrong with it, with
compound?
leaving it at 1 plus root 3 over 1 minus root 3?
What's wrong? Yeah,
Yeah.
because you want a fraction in the denominator. It can simplify further.
Okay.
See, at that point, there's not much more simplification unless you rationalize the denominator. That's it. Right? So if you put 1 over cos 75 in the calculator, it should give you that, but rationalized. Very thirsty, you actually.
I'm replenishing all the water I lost.
Yeah, dehydration is bad when you're sick, eh? Okay. Got another horrible one for you. I'll just. What the? Yeah. So that was one set of questions from one past year paper. Right, so you had 20 marks was that 1.1 to 1.4.
So I would have lost some marks. Well, I would have stopped there.
At that point.
At that point where it's got 1 plus root 3.
You know how you know where you can simplify to the furthest point? Put 1 over cot 75 in your calculator.
1 over?
Cot 75. Or just put tan 75. Because it's the same as 1 over cot 75.
2 plus square root 3.
2 plus
Square root 3.
the final answer. Yeah, because they rationalize the denominator. But you would have looked at that and known that that's not 2 plus square root 3. Yeah. You all got it? Yeah. You wrote it?
Yeah, got it.
You wrote it?
Yeah.
Take a picture.
Take a picture. Do it again.
Yes, sir. And so what we did now was last year's trimester 2 paper. The chick section for last year's paper. Right? Okay, this was the 27th July 2021 paper. So, question is solve for x given sine 2x equal to cos x over 2. How would you solve it? You're going to use double angles. Okay, so let's just say you use double angles, right? You're going to say 2 sine x cos x is equal to cos x over 2. Yes? What would you do after that? Okay, so you have told me that you would say 2 sine x cos x equal to cos x over 2. Right? what would you do after that? How can you simplify? How do we? Can we do anything after this? Looking at it? Any rules? Anything else we can change here? No. So is this gonna work? No. Eh? What else can we do? Remember, we're trying to solve for the value of x there, right? What would be the best thing to do is try to get rid of the sign and the cos. Right? Like how we would solve for any question, we'll try to get rid of your other variables and keep x, right? Now, last week when I told you if you had something that had sine and cos and you want to convert one to the other, what would you use? The other day? What we learned the other day? Huh? The last section we looked at? The one in the 90 minus 90 plus? Co-ratios, co-functions, right? And remember that?
Yeah, okay.
So we can either convert this to cos or convert this to sine, right? If we convert this to cos, how would you write it out? In terms of cos, what will equal to sine of an angle?
It's sine 90 plus.
It will be cos 90 minus the angle will equal to sine of that angle. Yes? Okay, so this will be cos of 90 minus the angle, which will equal to sine of that angle. And this is equal to cos of x over 2. Yes? Now what will happen to your cos's? It will cancel, right? So it will just fall away. So you left with 90 degrees minus 2x equal to x all over 2. Right? 90 degrees is equal to 2x plus x over 2. It's 2 plus half, right? Which is 2.5. You left with 90 degrees equal to 5 over 2. X 5 over 2 is 2.5, right? You multiply this, you left with 180 equal to 5x, and then this is equal to 36 degrees. Right? All the same, right? When you came to this point, you would have came to the summer here, you would have said 2.5, and you would have just said 90 over 2.5. You would have came to your answer. Do you understand what I did? So all I did was sine 2x, I know, but I know the first instinct is because this looks like a double angle, right? So you would have wanted to convert it into 2 sine A, 2 sine x, cos x, right? But remember, you're not going to go anywhere with it. And because we have one or the other, it'll be nice if we get anything on this end to cos or anything on that end to sine, it will just fall away, right? And then we can just solve for the question as normal. We can't use general solution because we still can't simplify any further. Okay? So that's why we did that. Are we all okay with it? Yes. Okay. Maybe that on the next one. I'll give you time to take it down. Let me just fill up the board first. Following identity.
Looks like I missed out a crucial part here.
And get the rules from them. Right. Nothing.
No.
Okay. Prove the following identity. Tan x all over sec minus 1 plus tan x all over sec plus 1 equal to 2 over cos x. So they basically want you to prove that this whole side here is equal to that. This here is not going to simplify any further, right? It's 2 over cos x. There's no need to simplify further. Okay. How are you doing? So now we look at our left hand side. Okay, go for it.
Try and change it. Everything to sine and cos. So sine will be sine over cos.
Mm-hmm.
And the sine could be cos. 1 over cos.
Mm-hmm.
So 1 over minus 1 and 1 over cos plus 1.
Mm-hmm. And then you're gonna go with that further. What's gonna happen? Gonna handbrake, right? Okay, you're gonna get stuck. Okay. So what you would do, you try and get your lowest common denominator. Okay? Looking at this, what would be your lowest common denominator? It would be sec x minus 1 times sec x plus 1. You understand that, right? And how we would do this, we would multiply this side here by sec x plus 1 and this side here by sec x minus 1. Actually, you multiply by the full thing to the top and bottom. But it will cancel out and you're going to get left with... Must I show you that part? Yes. Okay, so you're going to multiply this whole thing here by the top by sec x minus 1, sec x plus 1 all over sec x minus 1, sec x plus 1, right? Those common denominators. What's going to happen? You're going to multiply this first part. Okay? This minus and that minus is going to cancel, agreed? Right? So you're going to get left with tan x into sec x plus 1 all over sec x minus 1 sec x plus 1. You understand, right? Now you're going to end up with here. This plus 1 is going to cancel with that plus 1. So you're going to get left to tan x into sec x minus 1 all over that. So this would be tan x into sec x minus 1 all over sec x minus 1 sec x plus 1. Understand? Yes. Now, what will you do? Multiply out the brackets. Okay? So you multiply out your brackets. And on the right will be a lowest common denominator. Right? So now we're going to multiply out our brackets. Tan x times sec x would be tan x sec x plus x, right? And remember, these are all over the same denominator now, so we can just add the whole top up, right? Then you'll end up with plus tan x sec x minus tan x from here. Understand? Yes. Okay? All over, if you multiply at the bottom, remember all of this here is going to be over that same thing, because it's the same denominator. So sec x times sec x is? And then that middle term will cancel, right? Because you're going to end up with positive sec x and minus sec x, which will become 0. They're going to cancel with each other, right? And then minus 1 and 1 will be? Minus 1, right? So this and that would cancel. So you're left with 2 tan x sec x all over sec squared x minus 1. Now go to your important formula. Go to your important formula. Are you at your important formula?
Yes.
Yeah? Right. Sec squared x minus 1 is equal to what? Tan squared x. Tan squared x.
1 plus.
Yeah, 6 squared. 10.
Oh yeah, tan squared x. Right? You don't have the formula. Why you don't have the formula?
Yeah, same as on the globe. You can take it.
Okay, so this would become so what would it be? So you'll see the one I gave you, 1 plus tan squared x is equal to sec squared x. Right? If you make tan squared x the subject of the formula, you're going to end up with tan squared x is equal, tan squared of the angle is equal to sec squared of the angle minus 1. So we can replace that with that, isn't it? Okay, so this would become tan squared x, which is equal to, so 1 and 1 cancel. Right? You're left with 2 sec x all over tan x.
Right.
Yeah? Okay. Oh, I have figured that maybe something good. Can you simplify any further?
Yes.
How?
Change the same to sin
Hmm.
and cos.
Hmm.
And you said 1 over cos.
And then the
Sec to 1
and
over
the
cos.
sec also earlier to 1 over cos.
Hmm.
Then they will cancel.
They cancel it.
Okay. No,
They will.
1 is 10.
So 2 is equal to 1 over
cos,
cos all over.
sin.
Yeah, they'll
Yeah?
cancel.
Yes.
Yeah, they will cancel.
They will cancel.
Yes.
So you're left with 2 all over cos x times
What's the feedback date?
next week. Yeah. It's fine. Wait, now something went off here. Even I don't know where I went off to. Because now this is going to end up coming to 2 over sin x, which is not 2 over cos x. But help us solve it here. Hi again. Let me just check something. I don't know whether maybe in the talking formula it's not. I'll keep it out of here. Wait, to see if I what?
That's it.
Yeah, it's 1 plus tan squared is equal to 6 squared. Let me come back to this one. I don't know why I'm not.
Did you get that answer?
Yeah, but then I realized I made a mistake too.
Oh.
Because I took from here I just took it as tan x. So that would have cancelled, be left with 2 sec x,
Yeah.
and then sec x is just 1 over cos x, right? And I end up with 2 over cos x, which is that. Which is what, remember, I had the same thing, but let me go back and sort this out and I'll come back to you, right?
Yeah.
Okay. But method is the same, right? Just keep on breaking up stuff. You got the TV there?
No.
You got the TV there?
No, on my phone.
Check something for me too. Okay, you can take it on the way time. Let me check it. Mathematics. How come you don't have the July paper? How come you don't have the July paper? You solving it, Emma? You solving it? Fine. This is true. See, what are them? 6 squared x minus 1 there. You need to remember it. Right? 6 squared x minus 1. They just convert it to 10. It's supposed to be 10 squared x.
Yeah.
Equal. Plus 10 squared x equals 6 squared x. Yeah, this thing, the question is wrong. It doesn't make sense. Because even in the memo, it did the wrong thing. The data sheet, I just showed you.
So
Like,
it should equal to 2.
it should equal to here. When you're taking on the question, make it
Sin x.
sin x. Because you should see when they deleted this is from the 2021 paper, right? When you're going through it, you will see that at the data sheet in the question paper, they got the rule as sec squared 1 plus tan squared x is equal to sec squared x. But then you'll see when they came in the memo, they got sec squared x minus 1 and then they just write tan. You can't do that, right? So it would be wrong. So change this one here to 2 sin x, 2 over sin x, and then yeah. Because see what happens, right? Sometimes when they're making a paper, exam paper, the paper may have an error, right? On the day of the paper, they'll send an email to us with an addendum saying, tell the students that on question 2.2, it should be equal to 2 over sin x. But they won't update it on the actual paper. So they'll send it off, and then that's what happens. Okay, sorry about that, but this is it. So you understand how we got to it, right?
Yeah.
Okay.
Yes, that's done.
Can you check it down?
Yeah, take it off. Am I still recording?
Yeah, still recording.
But yeah, see, there's a nice question too, because then they make you do lowest common denominator, you do a whole lot of cancelling, you use the other formula. Just keep on breaking wherever you can break it up.
So in a case like this, like how we started, say 10 sine over cosine, so
You can try it.
Will we get there, or we'll end up doing a lot of steps and realize it's
No,
being a cycle?
you can try doing that one, cause you're gonna end up having to do the lowest common denominator one, because see when you break this up, okay, see if you break this up, right?
Yeah.
You're gonna end up with 1 over cos minus 1, 1 over cos plus 1. Then you're gonna change that 1s into cos and cos, but then you can only multiply to this portion. Then you're gonna end up with a whole long thing plus a whole long thing, and then you must try to simplify it more and more. It's always nice to get everything in terms of one denominator first and then break it up, because it's easier to work with that. Typing time looking for. Leave, let go. Blend right will leave at 11, and the rest of them, I'm gonna speak to them before they go. You finished all the system? What's the 10? What's the 10?
That's 25 to 11.
25 to 11. Okay, tell them work with C13 after come this now. Everybody is that. Okay, tell them you can work with C13. Yeah, because they got C13, all of them got C13. Yeah. It's so nice having 2 classes there. Works like that. It doesn't work with 2 over cos. We made a mistake. Because I substituted a number for x and then I solved.
Okay.
If you put it the same number for 2 over cos, it doesn't work. It only works for the same. Yeah, so make a note of that, right? That it changed everything. Oh, you're ready for that? Okay, right. So, this question here, simplify as far as possible, and they gave you this whole long equation, right? Let's simplify. Sine squared of 180 plus the angle. 180 plus is which quadrant?
Second quadrant is positive.
Third.
Third, right? Third, and sine is negative in the third. So this will become negative sine squared angle. plus 180 minus is which quadrant? Second. Cos is positive or negative in the second? Negative. So this will become negative cos of the angle times cosec 90 minus 90s. With 90s we use co-ratio, right? So what did it become? Sec of the angle all over tan 180 minus 180 minus is which quadrant? Tan is positive or negative in second? Tan negative tan of the angle times tan 90 minus 90 is co-ratios. 90 minus would be cot, right? Cot of the angle equal to minus sine squared of the angle minus cos of the angle. Sec can be broken up into what? 1 over cos of the angle, and the negative tan of an angle times cot can break up into 1 over tan of the angle. What can happen? Cancel, 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 cancel. What answer you left with?
Positive sine squared. It's minus sine square angle minus 1
Is there, right? Because when this and this cancels, what number you left with?
minus 1.
You left with minus 1. So when you're writing it, minus sine squared of the angle minus 1 all over, and if this and this cancels, what you still left with?
Minus 1.
Minus 1. Normally we have a positive, we don't show the 1 because anything over 1 and stuff would be that same number. Now this minus 1 will change the sign to what? So it becomes sine square of the angle, and this, and that's your answer. We okay with it? You look very angry.
No, that's something.
Okay, let me do one more question and then you all can take it down. This side here, you have done everything?
Yeah.
Okay.
Yeah, they still have 90 minus. I'm still getting copy back and stuff.
Yeah.
I think it's sweet.
Right, let's look at this, right? If tan alpha is equal to 12 over 5, where the value of alpha or the angle lies between 0 and 90, determine without using a calculator the value of 5 sine x plus 12 cos x. How would you do this?
You need to find the hypotenuse.
Right. So, remember what they gave you here, you can do this. Right? That's a triangle. If I say alpha is here, 12 will opposite over adjacent, 12 will be here, 5 will be there. So they told you alpha lies between 0 and 90, so this is between 0 and 90 if it was on an axis, right? So we can call that there. Determine without using a calculator the value of 5 sine x plus 12 cos x. They never say 5 sine alpha plus 12 sine, plus 12 cos alpha. So you can call this side here x, right? So you'll understand so far what I'm doing, right? Okay. Now first thing we need to do is solve for the hypotenuse. Okay. Now, so I'm just going to say r squared or hypotenuse squared. Remember, without the use of a calculator, is equal to 5 squared plus 12 squared. 5 squared is
25.
and 12 squared is
144.
if you add those two numbers, what you get?
169.
And if you square root it,
30.
eh? Okay. So now this here is 30. So now we got our values. So therefore, 5 sine x plus 12 cos x will be equal to,
Expect me to know the square root of 169 without using
it's common ones.
Yes.
There's 5, 12, 5, 12, 13. The other one was 3, 4, 5.
Yeah.
3, 4, 5. 3, 4, 5, 5, 12, 13. There's a couple other ones. I can't
Just
remember.
add up.
They just add up and give you these things here. But anyway, what is sine of x? Sine is what? Opposite over hypotenuse. If x is here, what's opposite? 5 over hypotenuse 13 plus 12. Cos is adjacent over hypotenuse. Adjacent to your x is all over. Still without the use of a calculator. Huh? 5 and 5 is what?
25.
All over 13 plus 12 and 12?
144.
This plus this is
169. 13.
do you understand what I did? You get it? So, based on the values that we were given, we know that tan of alpha is equal to 12 over 5. And they told you that alpha lies between 0 and 90. So, if you had an axis here, this would be 0, this would be 90. So, your angle would be formed there. So, we drew it. Alpha, tan is opposite over adjacent, opposite over adjacent. So, we wrote the value of 12, we wrote the value of 5. They asked you for in terms of x, not alpha. So x would be the other angle. Okay? We needed to know this because for sine, it's opposite over hypotenuse. For cos, it's adjacent over hypotenuse. So we use theorem of Pythagoras, we solve for that. We wrote the formula down again, and we substituted for sine x the value of sine x and the value of cos x. Simplified. And that was the 2021 trimester 2 trick questions. Okay? Take that down. Let me pause the video. Speak. They're not gonna know. One job. Okay, guys, for those of you all who missed what's going on, at this point I would like you all to pause the video and go through question 1.1, 1.2, and 1.3.1 and 1.3.2. Okay, thank you. And that was Temba's fault.
My apologies.
Oh, yeah. No, I forgot when I went out and I came back, I paused it.
You confused me a lot.
Me?
Yeah.
Where?
Hey.
Oh. Main thing is that rules sheet, familiarize yourself with it. Do maybe on one example from each thing on how to use the rule, and then come to this one. That's the only nice thing about maths. You can write down all your formulas do two examples with it, familiarize yourself with it, and throw yourself in the past paper. You're writing this week, right?
Mm.
You're ready?
No.
So this thing of changing that sign to cos, it only happens when you got the 90 minus.
Or 90 plus.
Or yeah, I'm talking about 90 minus or 90 plus. If anything over and above that, it's just
The
applying
180s and stuff is just your cast diagram.
Okay. So if it was 270, I'll just continue as normal.
Yeah.
Okay.
But you very rarely see them put 270s in there. See, like for 270, you'll also follow correlation rules. For 90 and 270, follow correlations. But for 270s, it will be the same as 90s. So if it's 270 minus, it will be the same, right? I've got a picture of it. I'll send that one too for the 270 rules.
Okay.
And then if you see 180 and 360, use the cast diagram. But yeah, you don't see it so often. Tomorrow we do graphs. This week we want to finish graphs. I have 2 weeks of calculus to go. It's gonna be fun.
It's all the graphs quickly, so
2 weeks of calculus.
1 week differentiation, 1 week integration. So at least at that point, science will be okay. But if I finish hydraulics this week, I think I only need next week to finish the last 2 sections. It's not long. It's not difficult. And then the last week we can just do partial papers for science and then maths. Or if I just need to do like 1 day of just maths.
if we weren't doing this, we have a 4-week thing, we wouldn't have finished syllabus.
If we were doing?
If we were just carrying on with us and by the incentive,
No.
we wouldn't have finished syllabus.
I would have had to do this. The prep for this is crazy.
Not even 2 more weeks. 2 weeks, yeah, to second.
Almost a whole week. Don't forget when you're learn the derivation for co-ratios and for double angles, right? Double angle one is easy, just remember how to do a compound angle, use the same letters, continue. Can I check out the circuit?
Yeah.
Yeah.
Okay. And ready for it.
This is okay, recording.
Right. So prove that all of this is equal to tan x. Tan x can't simplify any further, right? So obviously we need to work with this. So you'd say left hand side sine of x plus sine of 2x all over 1 plus cos x plus cos 2x, right? Make it equal to 10. Make it. what you do? Keep sin x, right? You're not going to change it now. There's no reason to change it, and there's nothing to change it to. Sin 2x is what? It's a double angle, right? So what it will change to? 2 sin x cos x all over 1 plus cos x plus cos 2x is a double angle. So it will change into
Cos squared x.
minus, what is plus?
Minus.
Sin squared x. Right? Okay. What would you do after that? How do we start solving this situation? Remember, your goal is to get it to 10. How? Well, 10 is what? Sine over cos. So somewhere along this line here, you would want to have sine in your numerator, cos in your denominator, right? As it is, we got sines in our numerator. Because if I pull the sine out as a common factor, right? Sine x into 1 plus 2 cos x. I took out the sine as a common factor. If I multiply it, I get sine x. If I multiply it here, plus 2 sine cos x. Right? So now I got the sine that I need in my numerator. In the bottom, I only want cos. But what's the problem? Right? But sine squared x can convert into what? 1 minus cos squared x. So this would become 1 plus cos x plus cos squared x minus 1 minus cos squared x. So sin x all over 1 plus 2 cos x all over 1 plus cos x plus cos squared x minus 1 plus cos squared x. This and this would cancel, and then you're left with sin x into 1 plus 2 cos x all over cos x plus cos 2 cos squared x. Now if I take out a cos from there, I'm left with, okay, so this is sin x plus 1 plus 2 cos x all over. If I take out cos as a common factor, cos x into 1 plus 2, what happens? Cancel, cancel. And then you're just left with, which is what? Right. So you would have broken it up here, right? Using double angles. Right? You would have known that your goal is to get it in you want 10, right? 10 is what you want. You can see a whole lot of sine on the top, a whole lot of cos in the bottom. You know that you're going to try and get into sine and cos. You're going to need like one term to have sine and all over cos. That will give you the 10. So when you looked at this, you knew if you took out the sine as a common factor, you have the sine that you need. Okay? The bottom, we need to make it into cos. So you just converted that, and that's how we got that. Did some simplifying, you came here. Then you can see you can pull out the cos you need, and you'll end up with something that can cancel there. So you cancel, sine over cos is 10.
You need to know the rules, right?
You need to know the
Once you know the
rules.
rules, it's so
And also, I'll give you all a data sheet of how the maths paper look. So you all will see what you have and obviously what you need to learn. Right? So you all can do that. Let me do the last question I need to do with you all, and then sharp. That's it, I can take out.
At least you know what you're working towards. You know? That helps.
This is not a bad one. Yeah? They want to determine cos 75 without the use of a calculator. Now the moment they tell you without the use of a calculator, you know you're going to have to use your triangles. So cos 75 degrees will be equal to what? 45 and 30. What is this? Compound angles, exactly, right? Cos of A plus B. So this will be cos 45 cos 30 minus sin 45 sin 30. Cos 45 is what? 1 over additional hypotenuse 1 over root 2. Cos 30 over 2, right? Minus sin 45 will also be 1 over root 2 and sin 30
1 over 2.
right? What does this become?
3 over 2
Minus,
1 over 2,
which is equal to
3 minus 1 over 2.
and that's your answer. This is one easy one you gave, right? To make up for. Right? That brings us to the end of our maths lesson. For all of you who came early and enjoyed it, thank you. Not joking, but guys, we did a lot of trig questions for today, right? We did 3 exam papers worth of trig. Are you okay? Right? You all saw for every question we did, some way or the other it applied to that rule page I gave you. There was nothing from these questions that we did that you all don't have in your rules. Okay? So you all got everything you all need. Just a matter of your practicing. And now all of this came from past year papers. I'm sure you all can see the importance of past year papers. Your textbook gives you questions up until a point, but they won't mix questions together or something like that. If they're teaching you cast diagram, all the questions will be cast diagram. If they're teaching you compound angles, all the questions will be compound. They don't do where they mix 2 different double angles and then from there you'll have to apply the other rule here where cos squared plus sin squared x equals to 1, that sort of thing, right? All that you're only going to be able to get from past year papers. Okay? Anybody have any questions on trig? Okay, that brings us to the end for maths. We shall have a break and do science. So what's the time?
11:30.
It's 11:30. We'll start science about 12ish, 12:15. Just eat. Okay. Cool.